Okay, so the first one we're going to do one about simplifying expressions. So very easy one, 2x squared plus 3y minus x squared plus x plus 2y squared. So let's just simplify this. What I'm going to do is I'm going to match up all my like terms. That's my x squared and my minus x squared. I can match up my plus 3y. Oh, I've nothing else to match it to, do I? There's no other y term there. There's a y squared there, but your y squared is a completely different relation. It's y squared. It's completely different. So I can match up, let's say I put that in a round. I can match up 2y squared with anything, can I? No, it's different again, isn't it? And I got an x term. So to be honest with you, the only things there I can match up, lads, is the 2x squared and the minus x squared. So 2x squared minus x squared is going to give you 1x squared. And then I'm going to say plus 3y because there's something to add it to. And then I'm going to say plus x because there's nothing to add it to. And then I'm going to add 2y squared. So there's really nothing you could do in that one. So there's your first one. You can't add it together any more than that. You can only add like squared terms, squared x terms, squared y terms. Okay, let's do something a little bit similar to that. Let's say, for example, I have 2x squared. By the way, let's go through some rules. Plus multiply by x. This can also be shown as 2x squared multiplied by x. There's two ways of showing it, lads. 2x squared multiplied by x is like there's a baby 1 up here. Okay, that's going to give you 2x and you add the little numbers on top, 2x cubed. That's what it means. The same for the one underneath is 2x cubed. But let's say, lads, if I said, for example, 2x cubed plus x. You can't do that. You can't add them together because they're different terms, but I can multiply them, just so you're aware of that. Let's do one about removing brackets. So let's say, for example, an easy one you could have is 4x bracket 2 plus 3x, let's say. Now, there's different ways you can do it. The most common way that I've done with she is this way. So you put the 4x down here and you do the 2 plus 3x in here on top, sorry. They're like two factors for all the world. They are factors. And we're going to find out what the end product is. 4x multiplied by 2, 8x. 4x multiplied by 3x plus 12x squared. Because there's two x's, lads. Look, there's an x with a little 1 and an x with a little 1. They give you x with a little 2. My answer for this question, so answer in a test. My answer is 8x plus 12x squared. Let's make it a bigger multiplication. Let's say I'll do an a's and b's. It's an a plus 3b bracket 2a plus 4b. These are factors. I'll write down a plus 3b down the side. 2a plus 4b on top. And what I'm going to do is multiply in. So a multiplied by 2a, 2a squared. A multiplied by 4b plus 4ab. Just push them together, okay? It's like x's and y's, but I'm showing you here, lads, you could have a's and b's for all the world. So you have to be used to that. Then 3b multiplied by 2a, 6ab. And then 3b multiplied by 4b plus 12b squared. Because I got a b with a little 1 and a b little 1 gives a b with a little 2. And now what I do is I draw my line. And remember, these are the two that always can add together. This one and this one. Actually, it just so happens here, I'm just going to erase that. In this particular one, we can add more. Or can we add any more together? No, we can't actually. Yeah, just these two. These are always the two you add together. 2a squared, I just write down. There's something else. Like if there's a 5a squared, I'd add it to it, but there isn't. Plus 4ab plus 6ab, they are like terms. 6 plus 4 is 10. 10ab plus 12b squared. That's my answer. My answer is, to that question, 2a squared plus 10ab plus 12b squared. Okay, so that's multiplication. Solving linear equations, here's another one for you. Now I'm making this up, so lads, it may not work, okay? Say I've got 2x, oh I don't know, plus 7 equals 5x what, like plus 1? And maybe the question is solve for x. So all we need to do here is we need to get x on its own. I normally say bring your x's to the left and the numbers to the right. So I'm going to have 2x, bring over the plus 5x becomes a minus 5x, equals 1 plus 7 becomes a minus 7. 2x minus 5x minus 3x equals 1 minus 7, and you're talking about minus 6. Now, it says solve for x, lads. It doesn't say solve for minus x. So what I'm going to do now is I want to just solve for x. So I'm going to make that plus now in a while, okay? I'm trying to get x on its own. So what I'm going to do is I'm going to bring over the 3 now next. Now be very, very careful. Minus 3x, can I just note for you there? Minus 3x is the same as saying minus 3 multiplied by x. Be very careful. When multiplication goes over the equal sign, you get division. So when you bring over the 3, I'm going to have it divide by 3. So minus x equals minus 2. The question asked me to solve for x. So all I'm going to do is I'm going to swap them. I'm going to bring over the minus 2 and make it a plus 2. I'm going to bring over the minus x and make it a plus x. X is 2. There's my answer. Okay, so let's say then we had to do solving inequalities. Okay, now they could be more difficult than that, but that's just an example. Say we had to solve for inequalities. Right, you just need to know we've got x can be an element of R. X can be a number. It can be a real number, it can be a natural number, or it can be an integer. When you do the number line, for the real number, you do shade. For natural, you do dots on the number line. And for integers, you do dots as well. A natural number, the smallest natural number is 1. So, and they're all whole, okay? So they keep going up like that. That's for natural. For integers, you're talking like it could be negative and positive, including 0. So you could have like say minus 5, minus 4, minus 3, going all the way up. You can go 1, 2, and it can include 0, okay? Real numbers is the whole shebang. Everything. And we'll give you an example of that now, okay? For that one now, I actually need to get one set up for it. Again, maybe I'll just use what we used already. Okay, so let's say 2x plus 5 is less than or equals to, what should I use up there? Just so I know, lads, this is going to work. 2x plus 7, actually, sorry. 2x plus 7 is less than or equals to 5x plus 1. Where x is an element of n. It says solve the inequality. Look at the only difference here, or I better write that down. Solve the inequality. Okay. Only difference, lads, is that there's an equal sign. Look, there's an equal sign there. I've got the Sharky sign down here. That's all it is. So you do it, you treat it like an equal sign. So I'm going to bring over the x's to the left, get the x's together. Like we did the last time, and bring over the plus 7 goes minus 7. Minus 3x is less than or equals to minus 6. Now, what I can do again, just like I did the last time, I can say minus x is less than or equal to minus 6 divided by 3. Minus x is less than or equals to minus 2. And now what I'm going to do is I'm going to bring over, this time I'm going to bring over the x here to make a positive. And bring over the minus 2, and that's going to make it positive as well, isn't it? So 2. Now, what this is stating to me, x is an element of n, is told me that in the question. And let's say it said, draw the number line underneath it. Draw your solution, we'll say, lads. Draw your solution on a number line. Okay, so this is what we do. We draw a number line. And I have to be able to translate this into English. So this is saying to me, the shark is going for X. So X is a number that is greater than 2, or it can be 2. It's greater than 2 or it can be 2. Natural number means dots. So I'm going to put a dot on 2, or it can be more than that. It could be anything. Sure, it could be 500,000 million. I don't know. So I put the arrow going on the end to say it shows me that this continues forever. There's one question on it. Okay. Let's try out another one. In the next group of this, what I'm going to do is I'm going to do next solution, like I'm going to do a real number one and I'm going to do an integer one. Okay. As another example. So you'll get it in part B.